Okay, so let's go ahead and take a look at some matrix operations, and then we'll get into maybe using some of those operations to solve some matrix equations. So taking a look at a normal matrix is just an array of numbers with dimensions, rows by columns. So this would be, the dimensions would be two rows going this way and three columns. So it's a 2 by 3 matrix. So A is a 2 by 3 matrix. So you always say the rows before the columns, and the rows go this way. And the reason you remember that is the columns are like the columns that hold up a roof, like columns. You would call those columns to hold up a roof. So think of it that way. Now, each position of your matrix is denoted by its spot in the row, in which row it's in which column it's in. So it sort of goes like this and follows the pattern. This is A1, 1. It's not A11, it's 1, 1. And it stands for first row, first column. This is A1, 2. First row, second column. And this is A1, 3. First row, third column. And why don't you go ahead and think about what these ones would be too. I'm going to just give you a second to think about those before I give you the answer. This would be second row, first column. So A2, 1. This would be second row, second column. And second row, third column. So if they ask you to find the value of A2, 3, they want the element of A in second row, third column. So first row, second row, and third column. First column, second column, third column. So your answer would be 2. So there you go with that. Now, in order to add and subtract matrices, your dimensions have to be the same. So if you're going to be adding a 2 by 2 matrix to any other matrix, the other matrix would have to be another 2 by 2. And so on with other sizes. The dimensions do have to equal. So this is a 2 by 2 and this is a 2 by 2. So it is able to add and subtract. In this case, for this example, they want you to subtract. And this is just a simple matter of subtracting each element. And remember, with subtraction, order matters. So here you would just say 1 minus a negative 2. So 1 minus a negative becomes a positive, which would be 3. 2 minus 3, negative 1. Now we'll go down to this next row, the second row. 3 minus 1 is 2. And 4 minus 0 is 4. And that's all you have to do, is just do entry by entry. Simple addition and subtraction. Addition is the exact same way. Alright, so let's look at scalar multiplication. Scalar multiplication is very similar to the distributive property, where if you're going to multiply a certain scalar, which is the 3, to each entry inside the matrix. So 3m would equal 3 times, well, let's just do it this way, 3 times each entry. So 3 times 3 is 9. 3 times 0 is 0. 3 times 1 is 3. And 3 times negative 2 is a negative 6. And so there you go, very similar to the distributive property. You just multiply everything inside, every entry inside the matrix by the scalar multiple, or the scale factor in some cases. So you might hear it called that as well. But scalar or a scale factor is just a number that you're going to multiply. Alright, so now let's take a look at an equation. We're going to use some of these operations in making an equation. So let's go ahead and just take an average equation. I don't want the numbers too big or anything like that. So let's look at equations. We're going to start off with 6310, 6310, some variable x, y, c, whatever you want to call it, minus 27 and equals negative 17, negative 10. So here's your typical matrix equation. And some of you might be thinking, oh my gosh, what is that? What am I going to do? Well, before we jump into doing this, I want you to remember what you did if these were numbers. If these were numbers, it would be 2c minus some number, let's call it 5 equal some other number were 10, okay? So if it were that, you would know what to do, correct? You would just do the opposite. You would add 5 to both sides. So you got 2c equal 15, right? And then you would get the variable alone by multiplying by its inverse is really what you did. You multiplied it by 1/2, same thing as dividing by 2, but you're multiplying by its inverse. And I want you to keep that in mind, that's what you did when you got the variable alone. And so we're going to have to talk about inverse for matrices as well. So this would just be 15 over 2. Okay, so that's how you solve linear equations. Now we're going to do the same process with matrices. Now the first thing we'd want to do is we want to get this variable piece alone, and we're subtracting a 2 by 1 matrix. So you're going to add that 2 by 1 matrix to both sides. And again, like I said, you just add each entry to its same spot. Let's write down what's left over here. 3, 1, 0, C equals, I gotta leave a little space here, but negative 17 and a positive 2 is a negative 15. And I don't know if I left myself enough room. Negative 10 plus 7 is a negative 3. Okay, so now what we would do is multiply both sides by the inverse of this. So we need the inverse, which is that matrix raised to the negative 1. And I'm going to show you how to do that in the calculator. So this is still 6310. Find the inverse. When you multiply an inverse of the matrix by its matrix, it's going to cancel out and you're left with just C. And you have to do the same thing over on the other side. Now the reason I wrote this is multiplication with matrices is not commutative, so we couldn't multiply it going this way. It has to be in front. So, and it's still going to be the inverse of it. I apologize there, but it's the inverse of it, which is 6310. So basically, when you multiply this by its inverse, it will cancel out and just be C. And whatever you get for this answer right here will be your answer for C. Now, what I need to do here is show you how to do that on the calculator. It's several steps to do the inverse by hand, but we're not going to do that. We're going to take a look at what we would do in a calculator situation. trying to move this over so I can still see what we want to put in, and you can see the calculator screen to the best image you can see there. Alright, there you go. So what we're doing is trying to put that last step of the equation into the calculator. So what we need to do is use the matrix button. If you go right next to the catalog button, the little book, which is right below the delete on your TI Inspire, you can pull up this menu right here with all the different symbols. So it's where same place where you go to get your fractions and stuff. So you're should be familiar with that button. And right here, since we're making a 2 by 2 matrix, we're going to make a 2 by 2 matrix there. If you don't have a preset one, you can always go to the 3 by 3, and when you hit that, you can change any of the dimensions you want. So keep that in mind, that any one that you wanted would work that way. Let me just get out of there. I didn't want that. Let me clear that. Okay, so go back, choose the 2 by 2 because it's already there. Put in your 6, 3, 1, 0. 6, 3, 1, and 0. Now, we want to take the inverse of that, which is just a negative 1, and we want to multiply that by the negative 15. Now, we need a 2 by 1 matrix, so pull that up. There's your 2 by 1, and you want to put in the negative 15. And that's the answer we got after the subtraction. And that's really all that was. It was really only one step. And negative 3. And you hit enter. And your solution, C, is negative 3, 1. So let's go back up to our final problem here. All this turned out to be, let's zoom out a little bit too. You can zoom out a little bit too. Okay, so this whole step here, when you multiplied this to this, was negative 3. I lost it on my calculator. It was negative 3, 1. There we go. Okay, so there you go. That's all there really is to it. I'll come back with a more complicated example in the next video. So I hope that helps, and if you have any questions, feel free to post them in the comments below, and thanks for watching.